This lesson is on multi-step trigonometry, so we're going to be solving right triangles using our trig functions, which we know are sine, cosine, and tangent. And we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what we're going to do is we're just going to work through some examples. So as you can see here, we have a triangle that is actually split into two right triangles, and we are going to have to find x right here. But we don't have all the information that we need in order to find x yet, so we're going to have to work through that. What I do have is this angle 53 right here, this angle 30, and this 46. So what I'm going to do is I'm going to split this into two different triangles. So I've got a right triangle that has an angle of 53, a hypotenuse of 46. And I can solve this by using trig functions. So I can solve for this piece right here, which is the height of my overall triangle. And I can solve for this piece right here. And we'll call that y. In the other triangle, which is smaller, I have 30 degrees. X, and this will also be h. So when I find h over here, I will also be finding h for this triangle because they actually share that side, because on this original figure, they actually share that side. So I'm going to first work on solving the bigger right triangle where I have a side measurement. So I can find h using this 53 by using cosine, because h is adjacent to 53 and 46 is the hypotenuse. So the cosine of 53 is going to equal adjacent over hypotenuse, so h over 46. Well, I'm going to multiply by 46 on both sides. So then 46 times the cosine of 53 is going to give me h. So then h is 27.7. We'll round to the nearest tenth. So on both of these triangles, here and here, it's 27.7. And remember, my goal is to find x. And now I have enough information on that smaller triangle to do that. So if I look at this triangle right here, h is adjacent, x is opposite. So then the tangent of 30 is going to equal opposite, or x, over adjacent, or 27.7, because h is 27.7. So I'm going to multiply both sides by 27.7. And 27.7 times the tangent of 30 is going to equal 15.99, and if we're rounding to the nearest tenth, that's going to round up to 16. So x equals 16. So what we've done is we've used trig functions to help us find the missing pieces. Here I want to find the measure of XYZ, which is this angle right here, to the nearest tenth of a degree. So for this, I'm going to be using inverse trig because I'm finding an angle. And this is actually made up of two different angles. So I'm going to have to find each of those and then add them together. So when I'm looking at that red part, I've got 5 and I've got 4. And if I look at that angle, that's the opposite and the adjacent in relationship to that angle. So I'm going to have tangent theta equals the opposite over the adjacent. So then the inverse tangent of 5 over 4 is going to give me theta. Remember, in your calculator, you're going to hit second tangent. So that angle is 51.3 degrees if we round to the nearest tenth. And then I'm going to find that blue half. So with the blue half, and I've got 4 and 9 on that triangle, I still have opposite and adjacent. So the tangent of theta equals the opposite over the adjacent. So the inverse tangent of 9 over 4 will give me that angle. So second tangent, 9 over 4, is going to be 66.04. And if I add those together, that gives me 117.34, which is going to be approximately 117.3. In this example, before we go over it, I want you to see if you can find angle DAC and angle BCD. And I want you to find segment or side CB. All right, so first let's work on angle DAC, which is this angle right here. And because this is an angle, I'm going to have to use inverse trig functions. And when I'm working with this angle, I'm actually going to be working with the larger right triangle and ignoring that segment CB. So what I'm working with is a side of 15, a side of 8, and a side of 17. So I have all three options, so I can use any of the trig functions. So if I wanted to use sine, then I would have to use the opposite and the hypotenuse. So that would be 8 over 17. So then theta would equal the inverse sine of 8 over 17. So that would be second sine 8 over 17. So angle DAC equals 28.07 or 28.1. Now let's look at angle BCD, which is this piece right here. And I'll be looking at this smaller right triangle that's created within the larger one that we just used. So with BCD, I've got 6 and 8 that I can work with. So 6 is the opposite, 8 is the adjacent, so I'm going to have to use tangent. So the tangent of theta equals the opposite over the adjacent. So then the inverse of that opposite over adjacent will give me theta. So second tangent of 6 over 8. And that gives me 36.87 or 36.9. Now when I'm looking to find BC, that's this segment right here, highlighting it in yellow. And there's two different ways that I can find this. I can use the Pythagorean theorem because I have both legs, or I can use a trig function now that I know the angle is 36.9. So let's do it both ways. So if I use the Pythagorean theorem, it's going to be 8 squared plus 6 squared equals c squared. So that's 64 plus 36 equals c squared. 100 equals c squared. Take the square root of both sides. So c equals 10. So that side should be 10. Now let's use trig to find it. So I know that this angle right here is 36.9, and this is the hypotenuse. So I could use this 8 and this piece right here. So it would be cosine of 36.9 equals the adjacent over the hypotenuse. I'd have to multiply by x on both sides. So x times the cosine of 36.9 equals 8. Divide by the cosine of 36.9 on both sides. So then 8 divided by the cosine of 36.9, and I get x equals 10.00. So either way, we got 10, so we could use the Pythagorean theorem, or we could use a trig function in that situation. In this example, I want you to try to find x on your own before we go over it. Okay, so this problem is a little bit like the first one that we went over. So we've got two right triangles, and we've got this x here that we are looking to find. Now, I need two sides in a right triangle in order to use a trig function. So I'm going to have to find this side right here before I can find x. So I need to look for information that I have that I can use to find that side highlighted in red. And I think that I'm going to be able to use the information from this smaller triangle because I have an angle and one side. And this over here would be the hypotenuse of this triangle. So I've got an opposite side and a hypotenuse. So what I'm going to do is I'm going to use sine. So the sine of 45 equals the opposite over the hypotenuse, which I'm going to call y for now. So I would multiply by y on both sides. So y times the sine of 45 equals 7. And then divide both sides by the sine of 45. And I'm left with 9.9 rounded to the nearest tenth. So then this side right here is 9.9. Well, that gives me enough information to find x because now I have an angle and a defined side and a variable side. So this still is an opposite and a hypotenuse. So I'm still going to use sine. So the sine of 45 is going to equal that opposite side, or 9.9, over the hypotenuse, or x. Again, x is in the denominator, so I have to get it out of the denominator by multiplying by x on both sides. So x times the sine of 45 equals 9.9. I'm going to divide by the sine of 45 on both sides. So then x equals 14.0. So that's how I would use trig functions to solve for that x.